Let's go ahead and pull ourselves back together. Let's go ahead and get ourselves started again, because we're actually making pretty good progress in what's going on. If you wanted to continue, all we're going to do is finish adding some beams to this little first level. We'll actually take a look at that little concrete structure and show you what you can do about that thing too. It's really pretty straightforward from here. We're just going to go through and there's kind of go to the ceiling plan. I'll add some more of those columns or those that structural framing back in here. Let's see what's going on. Did I go through and turn it off? I've got the coordination view. I'm looking at the level 1 ceiling. That should be showing there. It's not showing. What did I remember or not remember to do? Let's take a look. Go back and see if my structural framing is turned off. That's it. We'll show those things. Okay, so I'm going to go through and add the remaining ones just to go through and kind of have a complete structure there. And to do that, I'll go back to structure, say beam, and I'll just go for this thing with the grids. It's going to complain some about the places where I have too much going on, or I have the duplicates going on. Add it back in there. Let me finish all that. I'm going to complain again that some of these things, actually, in this case, that's what got me in trouble, was level 1. Let me undo that. Let's try that again. But don't feel bad if you're getting that error message the first couple times. Everyone does it. It's a real easy one to kind of run into problems with. So, just cancel. But I want to say is put them on level 2. Remember to do that. I'll go back and grab these grid lines. And what I'm expecting to happen here is it should complain a little bit about my overlaps. That's okay, I'm ready for that. Just like that one, an overlap in there. Okay, so hopefully now we got some sort of structure that looks pretty good. There. Okay. So see if you can get yourself something that looks like that. Just has some basic framing elements in there. You can try to change the size of those things. Just a real brief look at that little structure down there in the corner with the structural walls and think about it for just a second. In terms of what's going on down here, basically we can go ahead and have beams bearing on structural walls. Structural walls have a couple different properties. They're useful computationally. They're understood as resisting gravity, resisting lateral forces. Okay, but one thing that you can do is actually have them bear. So for example, if I go through and try and draw a beam, and I just have it kind of hanging out here and it's going off into space, actually it'll let me do that. I was sort of half expecting it to go through and complain at me and tell me that it's bearing on a non-bearing wall. I guess it's not hanging on a wall. That's probably what the problem is there. But what I can do is go through and have a little bit of a hybrid structure where, for example, I might have some columns here in the center. I can put some beams in there, which are going to go from here to here. And then when you get to the point where you want to actually, oops, I got that at level 1, which of course is not where I want it to be. So like everything, don't get ahead of yourself. Okay, I'll go back to level 2, which is where I want to put that. That's steel to steel. Oh, I'm looking at the level 1 floor plan. We go to the ceiling plan. That'll look right. Okay, so here I am. I got all the steel going to the columns, but now I want to start actually bearing on the outside walls. And I think this is actually what you need to do in your structure, is to go through and just bring it across to the concrete wall. And that'll be okay. It's understood as doing that. At a first cut, it's not going to go through and model in the little brackets and the connections for having those things hang off the concrete wall. You go back in at another level of detail and add some of those things in. But at least at the first cut, we'll understand kind of what the lengths need to be and that it is actually supported by that wall. So that's okay. If you go through and turn on that structural wall property, you'll be in good shape. Actually, let me do the other thing. Turn off the structural wall property, see if I can sort of break it the other way for you. Okay, so this this wall is no longer structural. Let me try putting a beam in there. I'll show you what that behavior is. I'm expecting it to give me a warning. It's not, so I'm wondering why it's not. Because it usually would sort of say, hey, you're trying to bear on a non-bearing wall. It could be confused because I had it be structural at one point or another. But in any case, your system may look something like this over here. In fact, I know it looks something like that over there. A little more complicated, but so go ahead and make sure you have these structural walls turned on. So this is great for the main columns, it's great for the main girders that float around. Typically happens at the next level is we're going to go through some intermediate beams. Because the intermediate beams are going to go through and span between the main girders. Actually, in your structure, I was looking at the pictures. To me, they look like they were at 8 feet apart. What's the distance between those intermediate beams or the joists? On your structure, you want to measure that? We'll go ahead and put them in around every 6 feet, something like that. Smaller beams are going to stand between that distance. Okay, so let's take a look at that. Actually, before I go much further, I should actually be a little bit better, though, in terms of how this is going to be modeled, just to sort of kind of give you like a little bit of nuance that's good in terms of construction. When you go through and you measure to level 2, level 2 tends to be actually the top of the floor, the top of the floor. And what happens is the beams, steel beams, don't actually run up to the top of the concrete. They actually recess them. What they want to do is they want to ride underneath. Oh, there's usually some of the concrete, a little bit of steel decking, some distance between the top of the subfloor and the top of the steel beams. They're actually recessed. And it'll vary a little bit on just on the specifics of your system, how big the concrete decking is, and so that underneath it. One very common measure is around 4 and 5 inches. What you actually want to do is that the set beams, so they actually come down a little low. They don't actually intersect with the concrete, they ride underneath. So it's good to put that in there. That'll be true generally with wood, that'll be true with steel. Concrete, it doesn't matter so much. So placing concrete, the height of the beams can be integral to the actual floor slab itself. So when you're doing concrete, you don't have to worry about this so much. But steel, it actually is a little bit of consideration. So this is one of those distinctions. When people first model, will often put the beams right at the same level. When you get a little bit better, you start putting them down a little bit further, and it's one less mistake that has to be cleaned up a little bit later in the process by someone who's actually doing the construction planning. So how you would do that is you could choose any beam, and every beam actually has something called an offset to it. So let's talk about that. You could go ahead and offset things, just at the individual sides. For example, here's my beam over here. If I wanted to have a slanting beam, I could go ahead and offset it. I could put like a 4-foot offset at one side, and it'll do something like that. It'll slant it and tilt it. That would be useful actually if you do have a slanted beam. Sometimes on roofs you actually have slanted beams. You can go ahead and incorporate kind of any sort of specific tilt that you need to put in there by kind of very precisely offsetting these. But I want to do something that's a little bit simpler. I'm going to undo that. Because what I really want to do is, I don't want to go up, I don't want to have to adjust both sides. I'd actually like to take the whole beam and just drop it 5 inches. And the easiest way to do that is to actually choose the beam, and you'll actually find that it has one property called the Z justification. What is that? That is, if you say place it at level 2, what part of the beam you want to place it at level 2? The top of the beam tends to be pretty close, or is it an offset? You could go ahead to the bottom of the beam, middle of the beam, but any part of the beam at that. You can switch between those, so if you want the bottom to be at level 2, I could raise it up, and it'll be on top as opposed to beneath the level 2. Let me switch that back over again to top. What I actually want to do is go through, though, and put a little bit of an offset value. I want it to be at the top, but I don't exactly want the top to be right at 0. I'd like to actually drop it down about 5 inches. How would you do
to actually put a little bit of an offset in here. So I'm going to put in here minus 0, 5.
Actually, let me talk about that for just a second. This is sort of a shortcut. Putting in dimensions, putting dimensions a whole lot of different ways. You can put in the feet in the inches if you really want to put that in there. You can go ahead and just put it sort of implicit that first number is feet, second number of inches. So 0 space 5, which is sort of the key way to go through and put that in there. Triangles across the middle.
We had a project that can I take the rabbit? I just want to borrow.
You have to actually sort of explicitly put in the distance. It's not smart enough at this point, at least in terms of manually what goes on. We could, when we get really good, write a little sort of extension to Revit that would go through and look at that value for the concrete slabs and automatically adjust the beams. So a lot of people are doing development work to kind of create little add-ons to it that increase the functionality. But the core functionality is you have to do it manually. You want it to be that smart, I know you do. Because that would be really, really good. Okay. Actually, this could be another instance of where a reference plane could be useful. We were talking about that at the break, where you could set a reference plane 5 inches below and lock it to the reference plane. There's different ways of sort of approaching that. But let me try just dropping that down 5 inches. What did I do that is so incredibly uninteresting but accurate? You drop that actually down 5 inches. You can still see there's the orange line, that's called the analytical model line. It sort of is at 0 because when we analyze it structurally, you don't think about it being there, but when it actually is, drop it down a little bit. Okay, so you'd love to drop all your beams down to about minus 5 inches. So how could you do that? You could go ahead and choose them one at a time and kind of drop them individually. You can do a lot of things like that. But again, let me kind of show you the quickie way. What I would probably do is just rotate the view so I'm looking at it from the front. Let me look at it from the side, see if that would work. I'm just going to do a drag to grab all those different beams and get all the beams in that selection. Looks like I have something else besides beams in there, so let me kind of talk about selection and filtering. I can grab, watch what happens. If I grab a bunch of things that are the same type, the properties dialog still shows properties that are relevant to all the things that they have in common. It looks like when I'm grabbing all these, I got 112 elements selected there, and there's something going on where there's another element, there's more than just a single category in there. And how I can deal with that is there's this filtering, which just allows us to see what's going on. And it looks like what I want to do is probably turn off the analytical beams. There we go. Now I just have the true beams, not the analytical model lines to do, so I can go through and put in the same distance for everything over here. Let's kind of pause there for just a second, because I did two things that were sort of really relatively powerful there. This big old drag select, you get a whole bunch of things at once, it's sort of a very useful thing. But this whole notion of filtering is kind of really handy when you need to change a bunch of things at once. For example, if I grab the entire structure over there and I filter it, you'll see I got some analytical beams, I got some columns, I got some structural columns, I got all these. So if ever I select more than I want to select, you just want to knock out the entire batch of things based on the category, this is the way to do it. So I'll take out those analytical beams and columns, I'll take out the structural columns, and as soon as I get a set which is uniform, it all has the same types of elements, then we go through and like the options. So that little nuance about the 5 inches, at first level, a lot of people will miss that, but it's kind of something I just want to warn you about because it kind of makes your models a little bit better and involves a little bit less cleanup at the end. Okay, let's switch back on over to that 3D view and take a look again. Oops, I am in the 3D view. I'm just looking at it funny. I've got to square it off. Okay, so we would like to put in those intermediate beams. Let's talk about those. Those intermediate beams at every 4 feet or every 6 feet. You could go ahead and start putting those in here. You could I need some intermediate beams. I'm going to ZF to zoom out, zoom to fit. I'll come back over here. I want to put some intermediate beams in this bay. So I can come over to the beam tool, and I can choose some sort of beam size. I'll put 8x10s in there. And I can very carefully measure to where I want them and start drawing them. And I want to put kind of level 2. That looks good. I'll put one over here. I'll put one over here 4 feet away. I'll put one over here 4 feet away. I'll put one over here 4 feet away. And whenever I start droning on like this, you're supposed to figure out that I'm going to show you a quicker way to do that. Because that sounds difficult to go through and do that all the way through the correct structure. No one would want to do it like that. Okay, so whenever there's something that's a very repetitive structure, there's probably kind of some relatively nice construct put together to kind of make that a little bit easier. And let me show you what that is. Under structure, you'll find beams. Beams are our old friends. We're pretty good on beams. Beam systems are amazingly like beams. They have this additional property. You can sort of say, what is the type of the beam? What is the boundary of the spacing you want to put that in? And what is the space between them? That's really good for floor joists. It's really good for rafters. It's really good for kind of sub-beams, purlins, all those kind of elements. Whenever you have something that's going to be really regularly spaced out, you think about height and then just scattering it around like throughout the region. Does that make sense? So let's show you how it works. If you choose a beam system, here's what happens. Okay. You still need to go through and choose the type of element. Over here in the properties, you'll see we have the choice of what it wants to be. I can make that 8x10s, I can make it concrete beams, I can make it some sort of K-joist. For you, they're these smaller elements, they're probably like 8x10s or something like that. You get to say, what is the spacing between those things? The spacing, again, whatever it is, whether it's 4 feet or 6 feet, or you're going to look it up and figure out whatever that is. We'll sort of put some sort of spacing. I'll put 5 in there just so I have something different. Okay. We then have this notion of how they're going to be laid out, a fixed distance, a set number of them, a maximum spacing, a clear spacing. Generally, fixed distance is probably the most common one that we tend to use. The whole notion of justification is, if that spacing doesn't fit precisely within the region, how do you want to break it? Keep the odd in, keep it centered and keep the odds at the outside, or push them all to the left, or push them all to the right, whatever it is you want to do in there. But let me go ahead and choose to sketch the beam system. Oops. Another choice we can make right in here, let me fix this while we're at it, is what the elevation of the beam system is. Remember that thing about the -5 inches? Put it in here, and all the beams systems have the same elevation difference. So let me just get that in there while I'm at it. 1 is 0, 5. Okay. Now we're ready to start sketching. I could go ahead and do automatic. Automatic's actually not too bad. If you choose automatic, if I click on the beam over on the left, it'll suggest that's where it wants to put them. When we first click, what it's doing is you're sort of not only saying where the boundary is, where it's suggesting the boundary, but you're also saying this is the direction of the beam system. We'll try to run these parallel. So if I click over on the left-hand side, we're trying to run them north-south. If I click them at the top, it'll try to run them east-west. So I can click it over there, and it'll drop them in. I can click over there, and it'll drop them in. And this is sounding awfully quick about how we can go through and put them in there. So all I'm really doing is selecting a bay, and then within that bay, it's going and filling it in. Now, the cool thing about beam systems is later on, someone actually does look at the drawings, they think, oh, it wasn't 5 feet, it was actually 6 feet. Something like that. So you need to go through and fix that. And the notion of really what the spacing is, it's just a property of the beam system. So if you want to go through and change a beam system so that as opposed to being spaced every 5 feet, it's every 6 feet, here's what you got to do. Hovering over that beam, if I get to hovering over that beam, the first thing it's going to suggest is, hey, I bet you want to change this one specific beam. actually want to change something about the system, that whole collection that's all working together, which we're going to do is actually sort of say, you know, that isn't what I want to operate on. I'm going to like suggest select the way selecting works when you lower something that you want to try and select it in the selection set you have. So that worked for us last week when we were looking at walls and tabs and we moved from a single wall to a collection of walls. Here it'll work with beams. So I can choose hovering over that single beam, and I'll tab, and you'll see that what it's actually going to do is suggest viewing these systems. And we'll even kind of put that here instead of for viewing if you want to select the entire system. And if that is the case, you can choose that. And we can try different spacings. I want to put them at every 3 feet. I want to put it at every 2 feet. I want to put it at every 4 feet or 6 feet or whatever it is in there. Or if it turns out that there's a different size, it's not going to be the 8x10s, it's going to be, this little hollow structural section. I can put that in there instead. Whatever it is, you can change all the different elements simultaneously. That's hugely powerful. You get, just really quick changes to a whole lot of structure very, very quickly. And that's good, because then what happens is after you've sort of guessed and estimated originally, when the structural engineer actually computes and figures out that a change needs to be made, it's really very few things that need to be changed to really recast the entire structure with the new elements. Okay, so it's really powerful to have this all object-oriented reflected. So let me put those back 8x10s. Okay, so when you're putting beam systems in, and I think you'll be using beam systems between all those main girders on your structure, you have the choice of either saying beam system, I can do automatic beam systems. Automatic beam systems are good when you have like a clearly delineated bay. Like in this case, it's pretty clear from its assumptions that it's going to go between those 4 bigger girders. It's going to just drop it right into there. You can drop it in here, drop it in there, and we're going to keep on going that way. If you want a little more control, because, for example, you have a floor opening. In fact, I think some of you will have this, where you'll have a stairway opening, or you'll have a slightly irregular shape. Okay. What you can do is actually sketch a boundary, as opposed to just choosing the whole boundary. So, and when you choose sketch, what it looks like is you choose the sketch mode. It puts us in sort of a sketch drawing mode. You probably did this if you've done any floors or you put any roofs together yet, where we're going to basically draw a boundary around it and create an element within that boundary. So here's what it's going to look like. I'm going to go through and do some drawing, or what I can do is do some selecting, since for many of the sides that I want to be using as the boundary, I just assume have it line up right with one of the existing columns, or one of the existing beams. I'll choose values with beam selection. So I can choose some boundaries over there. Whatever you can pick, this is almost like the offsetting, whatever you can pick and hang it off of another piece of geometry, do that. Now all of a sudden, I have columns which are hanging off the grids, I got beams which are hanging off the columns, I got beam systems which are hanging off the beams, so any stretching is going to be really resilient in terms of following and adapting to whatever you do. But if you need to customize that boundary, this is what sketching mode is good for. I can go through and, put a hole in there, or whatever it is. And when I put that boundary in there, it'll put the system in there, but it'll honor whatever the boundaries you put in there. So if you have a notch out because of some atrium, or whatever it is, you have a stairway opening, you can cut holes in there, and it won't put beams in that location. So when I say finish, I'm missing. I still need to clean up a little bit in there. I'm going to put the beam system in there. Go back and kind of patch in some specific little beams to kind of fix that. Okay, so beams, they're really good that way. If you go through and put in a beam system and later on you figure out, oops, I got it in the wrong direction, I should sort of shift things around a little bit because it's not really where it's going. to worry, that's really easy. It's just a property. So if you choose any of your beam systems, let me tab to grab the beam system here. Why aren't you selecting for me? Here's one. Let me, oh, it's interesting since it's auto-placed. It won't go through. Let me switch it so instead of being auto, I can edit the boundary. There's the boundary. If I need to change it so it goes in the other direction, what you do is under the drawing tools, there's actually this notion of the beam direction. And if I need to change north-south, I can switch over to that, and it'll flip it going in the other direction. You could actually even have them going at funny angles if you want to, although it's not very common. Take that beam system, again, I'm going to edit it. I'm in drawing mode. We go to the beam direction. One of the choices there is, I got these boundary lines. I can actually draw a line. So if I want the beams to kind of go at some sort of weird angle like that, do it. So really whatever it is that you can put in place. Okay, so you're going to go through. You got your columns, you got your beams, you got your beam systems. You're looking pretty good. Okay, you do all this hard work into level 1. You're looking pretty good. Actually, one other thing you may need, I think on your structure you have some K braces, or you have some X braces, one or two of those. Not to worry, just another structural element. I'll do that in 3D. It's a little bit easier to see that way. Braces, again, just another kind of structural element. Go to the Structure tab, choose Brace. You get to kind of choose really what the element is that you want to put in there. I'm going to do this with 3D snapping, because 3D snapping will be a little bit easier for me. And kind of zoom on in there. I'll put some in this last bit over here. I'll say 3D snapping. I'm going to choose these 8x10s, although maybe I'll do these hollow steel sections. Maybe those are a little bit better for the K braces. And I will snap from the base over here. Let's see if I can find, it's hard to get the middle sometimes. There it is, there's the middle. Come over here, get the middle over there. Now, you will look at that and say, wait, that looks pretty good, but it's not looking all that great. Right up there at the top. Let me kind of put that back to just line so you might be able to see it better. Because it's got the brace kind of running through there, but it's a little rocky right there where the connection is. It doesn't really look like a good welded connection. We can adjust that and hope to be sort of get it to the point where it's actually true fabrication detail. Then the first pass, this is probably close enough to get you going in terms of understanding where those braces are. It's going to analyze properly. There's a whole next step and some add-on tools that really help you do good bolted steel connections. Make that right. So whether you have K braces or whether you have X braces, again, if I had an X brace, I might just do something like this. And again, this won't look quite right as a start because there's going to be a little bit of cleanup at those intersections. But what will happen, and this is something you have to watch out for, even as you model, this gets to the whole level of detail argument. As you're designing, and first just trying to work out how the building is going to be and how the structure is going to work at a first level, it's probably not worth your while to go through and model in great detail every bolted connection. So you want to sort of get the big elements in place, sort of understand what the sizes need to be. If those are all looking good, then we'll go back and at another higher level of detail, start adding that real fine fabrication detail to really get away. So don't make the mistake, it's something we're all really tempted to do. You're looking at this 3D model, and it looks so precise, and you want it to be just right. You don't have enough hours between now and the end of the semester to go through and model this to that really fine level of detail where you're really worrying about every bolt. It's going to take a team of 100 people all working together to really get to that. So you have to sort of be used to this notion of it's kind of systematic inaccuracy. We know there's things that are always to be improved upon at greater levels of detail. We live with it.
Inaccuracy you can live with. So I think one of you guys asked me about level of agreeing on that, have, I guess, arranged that I'll post the document tonight. Please have a look at it. There are different systems. It's pretty detailed, actually.
Yeah.
All examples of areas.
So what I want you guys to be sure to do is, as you guys are working as a team, make sure that you're all agreeing at what level of detail you want to be modeling. Because if someone's modeling at level 200 and someone else is modeling at 800, poor Miss 800 is really spending an awful lot of time modeling that level of detail. What I always get a kick out of, I feel sorry for my students who are, when we're doing stairs and railings, we're doing this, conceptual design when they're putting in these fantastic stairs, and they're worrying about the fact that the railing's kind of missing by 2 inches, and it just looks really bad in the rendering, and it bugs you, and you can easily lose 4 or 5 hours trying to fix that. But it's just really not worth it, because this is a conceptual design, and we may go an entirely different way. So those 4 hours you're going to put into kind of making that railing work, it's not important yet. It will be later on, but.
And we'll talk about it in the second half. Depending on what you want to do with your model, then we'll need to change it. And this is another area that I want you guys to see together, get the documents that I put on Blackboard, and look at the project drawings that decide as a team what the level of. We asked you to do ability treatment, so define your ability treatment. Okay, follow it.
Okay, so how are we doing in terms of, how are we feeling about sort of this basic structural steel modeling? Is that all feeling pretty good? What's going on? Okay, if you're feeling pretty good about that, excellent. We can also go ahead and put a floor slab on this. This is one of those things, again, where the architect may have put an architectural floor in there, and here you want to put a structural floor in there that actually includes the metal decking, includes all that. Or we can just go through and put a floor in here. It works very much the same as it does doing it architecturally. If I'm looking at, I do the level 2 floor plan, I can say that I want to put, hang on, look at my floors, my structural floors. I can choose the type of floor. A very common one is this notion of the 3-inch lightweight concrete on the 2-inch metal deck. Yours may be a little bit different, but it's probably pretty similar. We'll put it at level 2. And then, I can either draw it, or a very common thing is, if we sort of base it on where the beam locations are, it may be hanging 2 feet off the sides, or whatever it is. I can start drawing some sort of boundaries. There. That's interesting. I'm trying to get it above it. It's not cooperating with me. I'll just draw a line there. But we're going to go through and put a floor in here. Now, when you're doing floors and boundaries and things like that, there's a lot of little techniques, tricks that you may know from AutoCAD or some other tools. Like one that's really good is this whole notion of trimming. That's a very good way of going through and fixing a boundary like this. Round it all out. We go ahead, I'll put one on the other side. Again, I'll offset over here. Well, let me do that, but I'm not going to worry about it too much. Right, do it that side. A very common thing is that rather than drawing all the lines independently, it may be easier to draw just a few lines to define things. We go through and trim to go through and kind of create the boundary. As opposed to drawing that as 15 different individual line segments, it probably is determined by like sort of one boundary you want to measure off of. So it's kind of okay to do that. This notion over here, this directionality, is this thing about is the deck going to be running left to right or right to left? Actually, given what's going on with my beam here, I am betting that the deck is going the other direction. Let me go ahead and switch that over. So I'll go to my drawing tools, and I'll change the span direction to go this way instead, so it'll run left to right as opposed to up and down. And now hopefully we actually have some sort of floor deck in here. Let's go ahead and take a look at it. Beautiful. Now, sort of achieving what we want. Looking at it as just sort of 3D geeker toys, kind of looking relatively neat and interesting in terms of doing that. But you get this whole notion of, can you really generate the construction drawing out of this? Is it really worth putting all the detail into this and really getting all the accuracy you want in there? And let me show you that it is, because what's happened is even what we've modeled so far, we can start doing things like cutting sections. Let me go to the level 2 floor plan and just show you. If, for example, I cut a section through the building, we did this way. And I can click on the head of the section and sort of see it. You're saying, hey, that doesn't look very good right now. It looks like a bunch of single lines, and that's not what I want. Kind of extend that down a little bit. That has to do with the level of detail, or the level of precision. Let me change that and make it look a little bit better. I turned it up to a higher level. So you can actually start to see now that what you're getting into is, I'll even turn down the line weights. We really are starting to get beams, the concrete decking running right on top of them. Have the level of detail you want. You're using your model and actually create all the construction details out of it. So it really is worthwhile spending the time to go ahead and make sure that that beam is 5 inches low, because you do want it to be underneath the deck. Let's go over there. Oh, that's just one of those little 8x10s. That looks like as I was putting in some of my 8x10s, I didn't actually get them at the right level. That's a mistake. What I should do is actually lower those down 5 inches so that they're hiding, or they're riding below the floor deck too. Again, I can do that minus 5 inches. It would be better to actually go back and fix the whole system. Okay, so this really does kind of have a high payoff in the end. The other thing that it's really good for doing is, if you go to those floor plan views, you're creating a building element model, so there's really an awful lot of information stashed in it. So you can look at this, like you often look at structural drafting. Great, all the lines are in place, but now I have to go back and add all the annotations. I have to go through and put in like all that detailed information to do the drawing. But the truth is, since it is a building model, you can actually just pull the information out of the database and actually display that. And the advantage of doing that is that if anything changes in the database, the right information will always be displayed, the current state of the design. And how that works is, if we go to the Annotate tab, we have this notion of tagging items. What tagging does is, as opposed to just putting text in there like you're doing drafting, it says, go ahead and grab database values out of the elements and display them instead. So, for example, I choose tag, and I go through and tag. Let me just turn off the leaders so they kind of come up very close. You'll see, as I go through and choose different elements, okay, it'll show the correct designation there. And the nice thing about doing it this way, as I put those in there, is if I go through and choose that element, and either the structural engineer or some analysis program changes it, as I change it, not only is it reflecting accurately in the 3D modeling, we'll actually pull right back that and basically the construction document will stay in C2. Okay, so that's one of the huge values of doing the building information modeling, is that there's no longer text which is severed from the actual meaning in the model. You're actually reporting the true value in the model. So hopefully leading to a lot less inaccuracy.
So is this coming along like together for a small database notion? We discussed this at the beginning, but probably without seeing it, because it's not easy to understand. But basically, you're looking at the same database through different views and building primitive relationships instead of and building objects instead of representation of objects. So this is where the information part of the information modeling comes into place, and we'll do different things with it. But I hope this is with these two sessions. Thanks.
good in a 3D view, but really those are good active values that I can use for computation, I can use for construction estimating, I can use for construction planning. We can all really have a shared understanding because we're not looking at a bunch of individual drawings. We're actually kind of sharing a true model of all the information that's ever been collected.
Yeah, and we're still, in some cases, creating drawings off of the model, which I will show you next week how to do that. But still, it's a database of building information that you're parsing and like presenting it in different ways.
Okay, let us look at just a couple more items to help you finish up in terms of thinking about the structure. I'm going to go back to the 3D view to do this. So I got that big old thing, which is kind of looking like a first floor, and again, probably in your buildings and my buildings, you want to start to copy that up to several different levels. And the idea is once you put it all to work once, you can probably copy and paste it to several different levels, and then use that as a basis to change it individually to get a separate level super. It'll save you a lot of work. Not only it'll save you the work, it'll also make sure that there's consistency and everything's lined up perfectly. You know, that you're trying to line things up and just draw on my level on top of your level. It's so easy to get a half inch off or a quarter inch off, and it just doesn't quite connect right the way you want it to be. You know, copying and pasting so that it's using the same XY coordinates will just guarantee accuracy. So you want to think about doing that. So how can you do that? We can really do it in almost any view, but I'll do it this way. Maybe I'll do it this way so you can sort of see it better. I'm just going to basically go through and grab that entire structure. Once I have that entire structure, I can copy it to clipboard. And then it's a matter of just saying that you want to paste it aligned to different levels. So I can go ahead and put it on levels 2 and 3. Actually, I always get this wrong, and you think I'd eventually, since I always say I always get this wrong, I would get it right sometimes. We'll try it if it's 2 and 3. If it's not 2 and 3, it's 3 and 4, because there's always this funny thing about whether it thinks of those beams belonging to level 2 or whether it thinks those beams belong to level 1. And again, I always get this wrong, so let's see if it actually works, or if I have to change it. So I'm going to copy and paste them. Let's see what happens. Okay, as usual, I got it wrong. What I did is I took
So it's the opposite of what you think it is.
It's exactly the opposite of what I think it is. It's because it thinks that those beams and that floor is actually belonging to level 2, so I shouldn't paste it to level 2 and 3. I want to paste it to level 3 and 4, because it already thinks level 2 is covered. It sounds really strange, but yeah, when you try this and it doesn't work, undo. And like, remember how much trouble I have with this. And I do this all the time. I can still never remember which way it is. I'll say modify. I'll say paste align selected levels, and I'll put it on 3 and 4. Again, the reason is it thinks that all those 4 beams actually belong to level 2. They were placed on level 2, so I don't need to recreate level 2. And the columns hanging underneath it thinks are belonging to level 2 also. Let's let it paste a lot. There you go. That's looking a whole lot better. Let's take a look. And hopefully you have something that looks sort of like that. Let's pause there for just a second. Give people a chance to kind of copy and paste things up. See if you can get something copied up to the other levels. And let's see if anyone has any questions about that. Because that's really, it's the heart of something that'll save you a lot of time. So, people generally pretty successful, or anyone have questions about trying to do that? It's too quiet out there, so I know someone has questions. So, how's it going from your perspective? Fine. Oh, good. Here. Okay. Just want to give you a chance to sort of play with that. Excellent. What I'm going to do next is show you how to put a foundation underneath probably a couple kind of big foundation systems you need to kind of think about, and it's all specified. Actually, for your foundation, is it a big slab or is it a lot of, what kind of foundation do you guys have on your building? So footings under the columns. Great. So like structural walls around the outside and then some sort of footing pads in the middle. Excellent. You can handle that. Okay, so let's talk about how you do that. The structural options include isolated footings, so those will be the ones that we put under the columns. The walls are like strip footings that we put around the outside. Okay, so those can be tall and skinny, or those can be like just like basement walls. Yeah, it can really be sort of whatever it needs to be to put a strip footing. Slab would be sort of just the overall slab. Often you'll have a combination of things where you'll have an overall slab that's 4 or 6 inches thick, and then at the individual column location you'll have a thickening right at that location ahead of the point load that's coming down. So some combination thereof. But let's talk about how you do it. It actually works out to be pretty easy. I'm going to actually go to level 1. This might be a little bit easier to do just in a floor plan. So let's kind of come over here to level 1. See what I got going on over there. You can still see those columns. They're kind of hanging around in there. Yeah, see if I can turn those up to make the thin lines turned on. Okay, so let's start with the whole notion of the isolated footings, the ones in the center, because they're actually pretty easy. Isolated footings work like this. You choose the isolated footing, and there is sort of several different types you can load in, including sort of a nice rectangular footing. Okay, these have different sizes that are sort of based on just different types. They have sort of a 6 by 4 foot one, 18 inches thick, kind of a 6 feet by 8 foot one in there. If this isn't the size you want, like how big are your guys? Do you know offhand? Are they sort of 4 by 4 or 5 by 5, or what do we know about them? Oh, they're pretty big. How thick are they? So 9 by 9, let's do that one first. And how thick is it? 18? Okay, beautiful. Okay, so we look at this and we say, well, great, we got these fantastic sizes, but I don't see anything that looks like 9 foot by 9 feet. And well, not to panic. This is the same as not having a door the right size or a window the right size. You need to make something the right size for you. We just need to customize the family a little bit. What I'll do is, maybe I'll start with an 8 by 6, but I will edit the type. And a good general technique that you're going to use so often to make things that aren't quite the right size, customized sizes, is you'll say that's a great starting point, but I want to duplicate it. Okay, and to duplicate it, oh, what is 9 feet? Is it 108? Last time I checked. I'm very bad about doing math offhand. Okay, and 18 inches. Okay. What I've done so far is I said, let's make a new one and give it this name. That isn't actually changing the size. That's just giving it a name that'll show up in the menu. Once we got that, still looks like the same old size, but we'll fix that. I'll make it 90 by 90. Okay, so what you're going to do is that same sort of thing. You'll make your 9 by 9, you'll make your 9 by 12, you make all the different variations of what you need. And you are ready to start placing. Okay, this is going to look kind of like what it looked like when we were placing columns. It almost always makes sense to go ahead and put them at the grid locations or at the column locations. And you'll see there's even sort of those choices. We could put them at grid locations or at columns. I actually tend to put them at columns because that is sort of the columns are hanging at the grids, and then the footings are hanging at the columns. Okay, so in the hierarchy of how things hang together, it sort of like keeps the hierarchy to how I like to think about it. So what I'll do is I will say add columns, and then I can just choose the different columns, maybe that column. I'll control click and get that one. Those look painfully non-square. I'm not sure if that's because of my monitor or if I actually need to go back and adjust those, but not to worry, since they're a type, I can go through and adjust those easily. So I've got these sort of different footings kind of hanging around. These are the suggested locations. When I say finish, it'll put them in there. Okay, let's take a look in 3D. Rotate that around, make sure I actually got them at the right level. They're looking pretty good. Okay, that wasn't too bad. We could handle that. Okay, let me just go back and verify those dimensions, just to be certain. Did I get them right? Yeah, it is 9 by 9. It's just, there's something going on. There's something weird going on with, I think it's more my monitor is kind of tall and squishy or something like that. We'll figure it out. Okay, next up, okay, so you got isolated footing. So still pretty good. Okay, we're ready for strip footing now. Strip footing, no worries. You're going to sort of enjoy that one too, because all you got to do is go to structure, say that you want to put in a wall footing. Here you just basically have a profile, so 36 inches wide by 12 inches deep, or whatever it is. It's going to sweep a profile along. Again, do you have any data about how big your guys is? 5 feet wide? How deep is it? We'll duplicate that. We'll sort of make that 60 inches by how deep do you think it is? And again, don't worry, we can always change it later. Was that 18 inches again? Beauty. Okay, that's just the name. So for the width, it'll be 5 feet. The thickness will be 1'6". Sounding pretty good? We'll say okay. Let's go back to that level 1 again, and we're going to draw these. Let's see what our options are. It's pretty much multiple, nice wall foundation. Oh, it's interesting. I wonder if it wants me to put it on top of a wall, under a wall. I'm thinking about whether it actually wants me to put a little bit of a wall underneath, which sounds kind of strange. It might be something we have to do there, because I think this should actually work. There's not a slab, it's definitely a wall. I didn't know it wants a little bit of a wall there. I'm thinking about the right way to sort of fake this in terms of what's going on, because it really is just a strip. But it's, oh no, but you actually do have walls, because you have structural walls hanging around there. Okay. You have a wall foundation because there's actually a wall there. I'm trying to put a wall foundation under the columns, which doesn't make sense. Okay, this actually, there is some cohesion in life. What you really have going on for you guys, you have these structural walls, which are all around the outside boundary. Doing something like that. Which are going from level 1, 0 up to level 2, or whatever it is. You got something like that going on. Okay, so if you have some nice structural walls around the outside, you can say the wall foundation. It should be here. Let me go ahead and change the type. That should be good. There we go. Now if I go back to 3D, that should be pretty good there. So that's what's kind of going around the outside. I have steel and concrete kind of working together around the outside, but that's what it is. You just need a wall to put a wall foundation underneath it. Okay. Let's go ahead and with our last couple minutes here today, show you one other sort of technique which should be used for the roof like the capable sloping of the roof graph. You want to go ahead and be able to go ahead and model those. Okay, so that would be a good thing. So let's think about how we're going to approach it first, and then we'll sort of like go from there. The fact that like all those little roof purlins, those rafter-like things are sort of spaced every 2 feet or 60 inches, whatever it is, sort of gives you a clue that it's probably a beam system. It probably is some very regular spacing. You're choosing some sort of profile, putting them at a very regular spacing and stuff like that. So beam systems in general work pretty well. The only sort of variation you have to sort of worry about though is that like for sloping as opposed to being perfectly flat. You might say, well, gee, how do I go through and do that? So let me kind of give you a real quick rundown on how that is, and this will go by fast, but it'll be in the video. So in case you missed it, come on back and check the video, and we'll sort of like get it figured out for you. But it's going to start with this notion, your architect is probably going to go through, or whoever's modeling that aspect of the project, and put some sort of roof on this thing. So let me just go through and do that. I'll put some sort of roof on this thing really quickly. Of course, I'm putting it down at some obscene level. We'll get that fixed up in just a second. There we go. And then, how about you? Over there. Why don't I be smart about this and actually do it that way, as opposed to trying to do everything in 3D. Let's do it this way. When you put on the roof, it's going to be at some level. Let me put it up at level 3 now, or level 4, whatever it is. I'm going to go through and draw it. I'll sort of pick these lines at the outside. Yep. Your architecture modeler is going to do a much better job than I'm doing right now. But it'll at least give me something to kind of get started with. Okay, that one's actually sort of on the wrong side. This one over here. The outside. Okay, let me try finishing that off. It's not quite in the loop. Let's get that fixed up. What's happening is, whenever we do these boundary sort of issues, it's very important about kind of closing the loop. And again, I'm realizing that's on the wrong side of the wall there, but I'm going to let it ride for right now so that we can complete it. Let's finish that up. Take a look at that. Where is my roof? Oh, it's a structural layer, so we're not seeing the roof because that's an architectural element. Let's try making coordination. Still not seeing my roof. Where did the roof go? Architectural. Again, not showing that roof. What am I doing? I'm just kind of goofing. That's what I'm doing. Let's go back to now. I can do something really quick and dirty, but it'll sort of demonstrate the point. All I'm really trying to do is get a roof out here so that you guys can have a technique about doing the structural part. Okay. Base level. I'll put it at level 4, apply that, say finish that. Oh. I know what's going on. This roof has no slope, which is really what's going on. What I have to do is, as I was going through putting those lines in, just make sure that there are slope defining lines. That's what it is. I say, it still doesn't look like it's showing up. Are the roofs not visible? Thank you. Okay, there's the roof. Okay, yay, at long last. It's always something. Visibility graphics gets you a lot of time. Okay, so this is a highly simplified version of your roof, but it'll start you into what you're going to do. So, you got that roof, things are looking pretty good, you're thinking that like everything's going to be okay. You want to basically get to match the slope of that roof with our beam system, or with our rationing system. So let's show you how you can do that. What you got to do is actually go through and create something called a reference plane, which is matching the slope of that. Because we can put beam systems on floor planes, we put them on wall planes, or we put them on a reference plane that's kind of matching some other angle, which is interesting. The slope of this roof is actually a reference plane, which is really, really interesting. So here's how that would look. If I come through and I just cut myself a nice section right through the middle of the building, and take a look at that, you'll see there's my roof. Okay. And what I really want to do is be able to have this beam system follow that slope. So here's what you got to do. Okay. We're going to create something that's like a level, called a reference plane, give it a name so we can sort of hang things and find it. But where we do that is under the Architecture tab. We can say, let's draw a reference plane, and we can either draw a reference plane or we can pick a reference plane. Pick always better than draw, in that if the roof slope changes, the reference plane will move with it. Okay? So that's a little bit better for you. I'm going to pick this edge. And that reference plane, which you might see kind of hanging around in slight green lines, a name. Like this is going to be the roof left. I'll go ahead and give myself another reference plane over on this side. I'll call that roof right. Okay. With that reference plane, we can actually start putting in beams that are sloping to match that. I'll show you how you do that. So we're hanging around over here. We want to put some rafters in here to go through and be these roof beams. Here's what's going on. So we go to the structural system. I go to beam system, and things are looking kind of good here in terms of what's going on. Notice that the work plane right now is set to level 4. Okay, you put it flat, put it right at level 4. What I actually want to do is shift that so the post plane is flat at level 4 and put it either roof left or roof right. Okay, and then it'll follow the slope for us automatically. And how I need to do that is, under the architecture tab, I can say set the work plane. And I can actually choose either roof left or roof right. And what this means is that anything I draw right now is going to follow, is going to be placed on that plane and follow that slope. Okay, so by doing that, if I go through and put my beam system in here, I'm going to have to sketch it. Okay, it's on that reference plane. If I go through now and draw some sort of boundary, and if you show the roof, this would actually work out okay. That's basically the boundary of it. If I showed the roof, I'd actually be able to see this better. In terms of the beam direction, it's going to go like that. And now I have some sort of system in there. Yours aren't big wide flanges. They're smaller little like cold steel elements or something like that we can choose. But let me go ahead and just choose these as a starting point. I'll say apply that. And when I finish, I'll basically get a beam system that's sloping. So what does that actually look like? When I come back to 3D, we got that side. I now have up here a whole series of beams that are basically following that roof slope. The good news about following that roof slope now is, in theory, the reference plane should follow the roof, so if the roof slope changes, the beams are all going to change with it. So that's the only variation you need to know about for the roof in terms of sloping. Is that go ahead and use the reference plane to hang on, and then like when you put the beam system in, and it'll have reference plane. Perfect test. Okay, we are just about out of time in terms of what's going on there.
And I can go